Lesson 39, Confidence Interval Estimation for the difference in two population proportions. So if we're interested in estimating how different two population proportions are, we'll conduct a confidence interval estimate to determine that. For the two population proportions that we want to estimate the difference between. To do that, we use the following to guide us through the construction of our confidence interval estimate. Starting with selecting 1 minus alpha, the confidence level. Unless there exists a compelling reason to do so otherwise, confidence interval estimates are constructed using the customary 95% confidence level, or 0.95 decimal. Now, after the two random samples from the corresponding two populations have been collected, and the sample results, x1 and x2, and the sample sizes, n1 and n2, have been determined, the 2prop_zint command on the TI-84 calculator will calculate the confidence interval estimate for the difference in two population proportions, p1 minus p2. On the TI-84 calculator, we would press Stat, arrow over to Tests, and then arrow down until the cursor is next to 2prop_zint. To select it, we press Enter. And then we enter in the data values, x1 and n1, and x2 and n2. And then we specify the confidence level, which is usually the 0.95 for 95%. Arrow down to calculate, press Enter. Under the 2prop_zint command, in parentheses, separated by commas, we'll find the confidence interval. The first number represents the lower limit L, and the second number represents the upper limit U. Together, they construct our confidence interval estimate. Now, the following formula is programmed into the 2prop_zint command to calculate the confidence interval. It involves the difference in two sample proportions, p1 hat minus p2 hat, which is the point estimate of the difference in the two population proportions, p1 minus p2. And the z times the square root of the quantity, the p1 hat times 1 minus p1 hat over n1, plus p2 hat times 1 minus p2 hat over n2, is the margin of error. And adding and subtracting the margin of error to the point estimate produces the interval estimate. Adding produces the upper limit u, and subtracting produces the lower limit L. This confidence interval estimate is constructed using the results of the central limit theorem. Therefore, in order for the normal approximation to be reasonable, both sample sizes must be sufficiently large. That is, both n1 and n2 must be greater than 30. With sample proportions, smaller sample sizes do not produce reasonable approximations. Therefore, this confidence interval procedure is never done for small samples. The confidence interval estimate for the difference in two population proportions, p1 minus p2, is expressed symbolically as L less than p1 minus p2 less than u, where L and U are the calculated values of the confidence interval. The confidence interval estimate for the difference in two population proportions, p1 minus p2, can be expressed verbally as indicated here, using the calculated values of L and U in terms of the issue under investigation. That is, we can use words of the problem to state that the difference in two population proportions, p1 minus p2, is estimated to be between the lower limit L and the upper limit U with 1 minus alpha times 100% confidence. When interpreting the results of the confidence interval, three situations can occur. One is when the first population proportion, p1, is less than the second population proportion, p2. In this case, when we estimate the difference, p1 minus p2, we'll take a lower value, subtract a higher value, and get a negative difference. In this case, when both L and U result in negative differences, the sample evidence indicates that the first population proportion, p1, is less than the second population proportion, p2, by as few as L or as much as U. So in this case, we estimate the values of the population proportions with a confidence interval. And then the confidence interval that estimates the difference in the proportions is estimating how near the two proportions can be, and the nearest the two proportions are estimated to be is L, and we can estimate how far the two proportions can be, which is U. Or the difference in the two proportions could be anything between the L and the U. So in this case, the population proportion difference, P1 minus P2, is estimated to be anywhere between the lower limit L and the upper limit U with a certain level of confidence. The other situation is when the first population proportion P1 is greater than the second population proportion P2. In this case, when we estimate the difference, P1 minus P2, we take a larger value and subtract a smaller value, which results in a positive difference. In this situation, when both L and U result in positive differences, the sample evidence indicates that the first population proportion, P1, is greater than the second population proportion, P2, by as few as L or as much as U. So when we use confidence intervals to estimate the values of our population proportions, the confidence interval that estimates the difference in these two proportions is estimating how different they can be as far as how near the two proportions are, which is L, and they also estimate how far the proportions can be from one another, which is the U, and it's estimating that that difference can fall anywhere between the L, how close they can be, and U, how far they can be, or anything in between. The other situation is when the L results in a negative difference and the U results in a positive difference. In this case, the sample evidence indicates that there is no significant difference between the first population proportion, P1, and the second population proportion, P2. If there is no significant difference between these proportions, then P1 and P2 are the same proportion. Thus, the difference between the same proportions, P minus P, equals 0. And 0 is always included in an interval that ranges from negative numbers to positive numbers. So whenever the 0 is included in the interval, the conclusion is that there is no significant difference between the two population proportions. Now, in the following examples, we'll be able to demonstrate how to construct confidence interval estimates for the difference in two population proportions.